This is Counterpart, the Case IH magazine meant especially for people who are interested in the best in parts product. Your host, the Manager of Parts and Service Management Training, Jeff Johnston.
Welcome to Counterpart. We'll be issuing this video magazine 4 times a year. Each issue will deal with 3 parts products. You can watch the product segments one at a time or all at once, whichever works best for you. You can also review the material from time to time, or when the segments contain information you'd like to pass along to your customers, keep the tapes available at your parts counter. We'll be covering many topics of interest to you, so be sure to watch for each new release of Counterpart. Let us know how you feel about the program and about other parts products you'd like to see covered. In this issue, issue number 1, we'll start talking about batteries, lubricants, and filters. And now, welcome to issue 1 of Counterpart. Batteries. Most of us buy them. Most of us wonder at some time or another just what makes them work. Is there magic inside of a battery? Are all batteries alike? Do prices, cold cranking amperage, and the warranties tell the whole story? Or should we know more? We'll talk about batteries with Steve Schmidtkins. Steve has been working around batteries for a long time. First at a gas station during high school, then while he was being trained as a diesel mechanic, then for the past 13 years in the parts department at Case Power and Equipment in St. Louis, Missouri. Steve, let's get right down to business. Should people know more about what's inside of a battery before they buy?
Sure, I think so. They can get by trusting the people that they deal with, but it always helps to know you're getting what you really need.
So what you're really saying is that price, cold cranking amperage, and warranty really don't tell them all they need to know.
Those things will tell part of the story, Jeff. For instance, our prices are competitive, and we can check sizes in the BCI data book. We can also assure customers that our warranties for batteries for off-road vehicles are the longest in the industry, twice the industry standard, in fact. But it's what's inside the battery that really matters, especially when you're dealing with off-road vehicles like construction and farm equipment.
In one way, all batteries are about the same. They're made of lead plates, positive and negative, in sulfuric acid. The chemical action between the plates produces electrical energy, enough power to crank an engine. But at this point, the differences begin. Wet batteries, those with the acid left in them, start discharging immediately, even before the customer gets them. So some batteries are dried. And the question here is, how dry? Our batteries are bone dry, the driest in the industry. They're oven cooked for 24 hours, so they have an infinite shelf life and are born only when they're prepared for the customer in our parts department. The customer goes home with a fresh battery, guaranteed fresh.
And you know, Steve, customers who buy for future use can benefit from that bone dry process as well. The battery can be stored dry, then when it's time to put one to use, they put the acid in and they know they're starting fresh.
That's right, Jeff. The bone dry process is a very important difference between batteries. And here's another. This is a standard calcium grid. The current flows along these paths up to the post. And this is a hybrid radial grid from a Group 24 Case IH battery.
Steve, looks to me like the current can flow more directly to the post on the hybrid radial.
It can. That shorter distance to the post means a higher cranking power and a faster charge. Both critical elements when you're dealing with equipment that has to work all day, every day.
What you're saying then is that manufacturing and design refinements like the bone dry process and radial grids are important when you want a battery to perform to heavy-duty standards?
Yes, and there's something else to look for too when you need a heavy-duty battery. It's an envelope separator. You see, all battery grids break down when they're hot. The lead particles fall because of chemical reactions and vibrations. Now, that's not much of a problem when you're driving along a highway. On a highway, a regular separator between the grids works just fine. It's when your machine is subjected to a lot of vibration, an envelope separator like the one we use in our group, 24 and 31 batteries, catches the battery particles and keeps them active.
That's very interesting. But how about the problem of vibration? Steve, I understand that vibration is one of the biggest causes of battery failure in off-highway equipment. Is there anything else inside of our battery to help cope with that particular problem?
Sure, there sure is. It's epoxy. I know it sounds simple, but it's very important because other manufacturers use hot glue to anchor their grids. We use epoxy. The epoxy costs more, but it withstands vibrations better and guarantees our customers the best.
You know, it sounds to me like you're pretty confident when it comes to recommending our batteries.
I am. It's nice to know that what you're offering the customers is really good for them. We've got the price, we've got the warranty, and we've got the quality.
In this segment of Counterpart, we'll be talking about engine oil. This is Paul Lorenson with Viscosity Oil, the Tenneco company that supplies lubricants to Case IH. Now, Paul's contact with engine oil goes back a long way since he first checked the oil in his dad's tractor and then through the years as he worked in parts marketing. Paul, why do you think we should be concerned about the oils in our engine? I hear a lot of people say that it's all the same no matter who you buy it from. Is that really true?
Well, Jeff, oils are different. Even oils with the same ratings can be different. But let's answer that first question first. Why worry about the quality of oil you're using? Here's the reason the quality of oil you use should matter to you. Equipment service. You can get the idea how oil quality varies when you realize that warranty claims are much higher for users of cheap oil. And that partly answers the second part of your question. Are all oils alike? Oils are not alike, and the price tag isn't the only difference. To get a better idea of the differences, let's take a look at how oil works.
Oil has three principal functions in an engine. First, it helps to keep the engine clean and free from rust and corrosion. Second, it acts as a coolant and sealant. Third, it forms a cushion between the metal parts, reducing friction and wear. That's the basics of oil. But from there on, its development gets more complicated. Additives are needed to create the kind of high-quality product you need for heavy-duty applications. So chemists and engineers work together. They design and test formulas that include additives such as detergents and dispersants to help keep the engine clean and to help prevent sludge and varnish formation. Oxidation inhibitors to help prevent oil thickening and deposits caused by high-temperature operation. Alkalinity agents to help neutralize acids. And anti-wear agents to reduce friction and prevent wear on metal parts. Once the oil is blended, testing begins. Testing is critical. The Society of Automotive Engineers, SAE, and the American Petroleum Institute, API, award their approvals and classification designations, such as the CD, on the basis of tests, like the diesel test established in 1955. In this test, a one-cylinder 1947 Caterpillar engine is run on a driven dynamometer at 2200 RPM, 40 horsepower, for 480 hours. That's the test everyone has to pass to get the SAE CD rating. We meet the SAE criteria and then go several steps further, testing a current model heavy-duty diesel engine on a driven dynamometer at full RPM, full horsepower, for 3,000 hours.
Jeff, as you can see, there's quite a difference between what a manufacturer does to earn a plain SAE CD rating and what is done to blend the high-quality diesel oil we blend for Case IH.
You know, Paul, I think that's a difference we can be proud of, too. But did I hear correctly? Was that SAE test established in 1955?
That's right, Jeff. But to be fair, SAE is considering a new diesel oil classification, closer to our standards. One of the reasons for improving the standards is the rising sulfur content in diesel fuel.
Over the past several years, the average sulfur content in fuels has been rising. This sulfur combines with water, which is a normal byproduct of combustion that condenses into the oil. When you add sulfur to water in the presence of oxygen, you get several acids, including sulfuric acid. All of these acids attack the metal parts in the engine, especially the bushings and bearings. It is the job of the engine oil to help neutralize these acids. The measurement of an oil's ability to neutralize the acid is called its total base number, TBN. The TBN is directly related to the ash content in the oil. The current CD standard calls for a 1% ash content, which gives you a TBN of 6 to 8. The new standard would be closer to ours, with a higher ash content, say 1.5%, and a TBN of 11 to 13.
In a word, oils are different. Even oils with the same ratings can be different. We're leading the industry with developments such as the additive package that increases the ability of diesel engine oil to neutralize acid. Quality differences like that are important, especially when you consider how the engine in off-road equipment is being used. For example, automobiles use about 30% of their available horsepower. A truck uses 60%, while off-road equipment such as farm and construction equipment uses a good 90% of their available horsepower.
Well, I know the equipment is designed to handle that kind of load. And I agree with you, Paul. We should give it the kind of high-quality protection it deserves. In this segment of Counterpart, we're going to do something special. We're going to look inside the manufacturing plant of one of our suppliers. The topic is filters. The plant is Fleetguard Incorporated. And the reason we're going there is to understand just what it takes to make a high-quality, heavy-duty filter.
The job of a filter is to protect an engine from damage by abrasion. The four basic engine systems, air, lube, fuel, and cooling, all require filtration. But the science of filtration technology is fairly new. Today, materials are analyzed with equipment such as this scanning electron microscope, which can analyze paper at a range of magnification from 150 to 3,000 times. 15 to 25 years ago, no one would have placed the emphasis where we place it now, on the highly refined media and solid construction that produces the spin-on, high-tolerance filters we use today. Filters begin here, in engineering, where the requirements of specific engines are considered in the design. Prototypes are tested to assure the quality of each component. Laboratory tests analyze material and determine nominal and absolute micron ratings of filters. Filters are rated by percentage of efficiency. A medium is passed through the filter from the barrier side upstream to the clean side downstream. The size of the particles passing through the filters are measured to determine the micron ratings. Here's a good way to visualize the size of particles stopped by a filter. The outside circle represents 50 microns, which is about the size of a human hair. The next circle represents 37 microns, which is the size of the largest particle passed through a lube filter. The next line represents 25 microns, the size of a white blood cell, which is larger than the largest particle that will pass through an 18-micron fuel filter. The difference between absolute and nominal micron ratings is that an absolute rating means all particles over 37 or 18 microns are stopped by the filter. If a filter has a nominal rating, that means that most, but not all, particles over 37 or 18 are stopped. The only way to be sure heavy-duty engines get the protection they need is to use guaranteed high-quality filters. One way high quality is assured is by using all resin-impregnated cellulose. When resin-impregnated cellulose is cured, it helps guard against moisture. Polyester is also used with the cellulose to add further protection against moisture. This specialized blending makes the paper the most expensive material used in the filter-making process. Adhesives are the next most expensive. Only high-quality adhesives, such as plastisol, are used. Once the end plates are in place and the curing is finished, specialized nut plates and springs are added, and the can is put in place and seamed. Then each filter is tested for leaks. The containers are painted, heat-dried, and packaged, with each lot coated. But the process doesn't end here. The filters will be spot-checked again before they're shipped. And the inspection procedures evident at every step in manufacturing will continue in the parts depots and dealerships.
Because high standards are maintained all along the line, we can honestly recommend our filter. We know our customers will save in the long run by protecting their valuable engines and engine parts with Case IH filters. And that, my friends, is the first issue of our video magazine, Counterpart. Watch for the next issue. Let us know what you think. And most of all, remember, we're dealing with the best.